So in this video we pick up where we left off from the last one. We were analyzing arguments using the ARG conditions. We just looked at, in the last part of the last video, when premises are acceptable and when they are not. So now we're looking at the relevance of premises. Let's first look at positive relevance. So we have here two premises, A and B. A, basketball is a game in which height contributes greatly to success. B, basketball is a game in which physical characteristics make a substantial difference in performance. So obviously it's true that if A is true, then B is true, and if we did not have A, then B would not be true. So if A, then B, and without A, B is not true. That's what's meant by the if and only if. So here is an example of positive relevance. As an example of negative relevance, look at these two premises, A and B. A, 1 million Iraqis died due to political violence between 2003 and 2007. B, the violence in Iraq was not prevalent enough to be called war. Well, here's a negative relevance. A does not imply B. A actually implies the opposite of B. So this is a negative relevance, not supporting premise, essentially. Here is irrelevance, usually pretty easy to spot. Here's one that's very obvious. Premise A, natural disasters such as earthquakes are beyond human control. B, humans have no freedom of choice in their action. Certainly not related to each other or relevant to each other. Here's an example of irrelevance, actually, in the form of the straw man fallacy. We would, many of us would accept the premise Valentine's Day is exploited and overrated, but the premise is a stretch. Therefore, we should abolish Valentine's Day is to sort of do that subtle shift. Oh, well, if you agree it's overrated, then we should just abolish it. So that's a fallacy of relevance. Another fallacy of relevance is the ad hominem fallacy, where the person making the claim instead of the claim is attacked. That's common, certainly on talk radio and television, political television shows. You find this happening all the time. The fallacy of guilt by association is a commonly occurring one in political argumentation. There is some degree of association between a candidate and some association, typically a loose association. That group that the person is associated with has done some things which are questionable or not accepted by a large part of people. Therefore, even though the candidate or person is only loosely associated with that group, they are guilty and should be. They are guilty because they have some association with them. So this is a fallacy of relevance. That association with the group, if it's loose, is not relevant to the argument. So if we have a premise where we are not sure whether to accept it or not, and the person using that premise in their argument just claims, well, it's very popular, so therefore it must be true, that's a fallacy of appeal to a popularity. That just because the premise is a popular one does not make it a valid one. And here's another one we saw earlier, the fallacy of appeal to ignorance. Just because something is not known to be true does not mean that it is false. So let's look on the next blackboard in a more in-depth fashion at inductive arguments, the type of arguments that we're going to study more, and the type of arguments that you essentially find for the most part in opinion pieces, the type of article that we're going to ask you to analyze. So let's give another definition of the inductive argument. and in them we're trying to extrapolate from experience to what we have not experienced under the assumption that known cases can inform unknown cases. Let's make two notes about inductive arguments. First, the premises and the conclusion are empirical, that is, they are experience-based. And two, the assumption or the conclusion is inferred using the assumption that the pattern outlined by the premises will persist. Now, obviously, that one is subject to scrutiny, but that's the way the argument is made. To convince you, well, if the argument is made well, then you are convinced the pattern will persist, or at least probably the pattern will persist. So let's look at this example of a common type of inductive argument, the inductive generalization, that the particular instances imply that most objects have this particular characteristic or feature. So here would be an example of an inductive generalization. 20% of 2013 students got to campus by bicycle. So we can conclude that 20% of 2015 students will, we should say, likely get to campus by bicycle. If we put the word likely in, then we've made a valid inductive generalization. A second type of inductive argument is called the statistical syllogism. It has the structure: most A's are B, X is an A, so X is probably a B. Here's an example: 85% of those living in Poland are Catholic. Jacek lives in Poland, therefore Jacek is probably Catholic, which would be a sound inductive argument. So that last argument, we should actually call it a cogent inductive argument. What are examples of inductive reasoning errors? A biased sample. So we infer something about the population which we cannot probably infer because the sample is biased. We make a hasty generalization, which is so we see an instance of something or an instance or two of something occurring, and we generalize that something will always occur when we do not have sufficient information to make that generalization. We make anecdotal arguments, which is pretty similar to a hasty generalization. We provide a few examples, and then we conclude that those are representative examples. And then there's two more, are composition and division. Composition, a generalization is made about the whole because of information we have about the parts. So there's a group and one or two members have a certain characteristic, so we infer the whole group does. The sort of the converse of this would be groupthink, where everyone thinks the same way and no one's willing to challenge it. And division would be where if we know that a group reaches a decision, we infer from that everyone in the group agreed, but we do not have evidence for that inference. So as we wrap up this video, let's look at one more type of inductive argument called the causal conductive argument, or causal inductive argument. First, let's distinguish between correlation and cause. Just because two things are correlated does not mean one causes the other. So let's look at that in more detail. So let's assume that A and B are positively correlated, which means that if there is a higher occurrence of A, we notice a higher occurrence of B. If that correlation is 1, then if we have 50% more occurrence of A, we'd have 50% more occurrence of B. And if we have a lower occurrence of A, we would also have a lower occurrence of B. So both those are present when we have a positive correlation. What can we infer from that? There are actually three possibilities. Let's list them below. So there are actually four. Actually, we're going to put four possibilities, and we'll add one more. One is that A does cause B. Two, B causes. This is when A and B are positively correlated. So the possible inferences are A causes B, B causes A. The positive correlation is a coincidence, or some other factor is the cause of A and B, or there's lots of factors that are the causing A and B to be related, and we don't know what they are. So just because two things are positively correlated, we cannot infer that A caused B, and that's a common fallacy. So in early studies of breast cancer, there's a study cited in the book we're using as a supplement where 90,000 nurses were studied in the 1990s. Let's write down the information, the relevant information from the study. So there were 90,000 women studied throughout the 1990s. 714 of these women developed breast cancer. 134 of the 715 were women who had a higher than average occurrence of animal fat in their diet. 123 of those developing breast cancer had a lower than average amount of animal fat in their diet. And the doctor conducting the study concluded that animal fat led to a higher incidence of breast cancer, even with just this very slight amount of evidence. And in fact, it was cited as 33% higher incidence. Well, this is a poorly developed association in causal. There was just a very slight, slightly larger correlation between high-fat diets and breast cancer than there was with low-fat diets and cancer. But to make the claim that this is causality was incorrect. The statistical study did not show that. So let's look at a couple of more examples of poorly reasoned inductive arguments in causal relationships. The post hoc fallacy: something occurs after something, therefore the first thing caused the second thing. That is not true. Just because it occurred later does not mean it was caused by the first incident. So let's look at one more fallacy of causal inductive reasoning: the objectionable cause. A occurred, B occurred, both A and B are bad. There is some causal connection between A and B, therefore A caused B. The error here is that there is just some causal connection, not a strong enough one to say that A caused B. And you find this type of argument often in political opinion pieces. Another causal fallacy is called the slippery slope argument. The thinking at the early era of the Vietnam War in the 1960s was that if Vietnam were to become communist, then the surrounding countries, Laos, Cambodia, and Burma, would become communist, then India would become communist, then Southeast Asia would become communist, then Asia, then Europe, then the whole world. And this theory was called the domino theory, which is a popular theory at the time, an example of the slippery slope argument. However, as the Vietnam War became less and less popular, the domino theory came into dispute or disregard, and as we saw that after the Vietnam War ended, even though Laos fell to communist control, Laos and Cambodia actually it did not extend beyond that. The slippery slope argument is a fallacious causal argument. Let's look at some ways called Mills methods coming from the philosopher John Stuart Mill, a philosopher in the 1800s, that developed methods that are still very useful today. So the method of agreement, factor C is present in all occurrences of H. That makes C a likely cause of H. The method of difference, ruling out factors. Factor C is not present in all occurrences of H, so we could rule out C as a cause of H. The method of agreement and difference. C is present when when we have an occurrence of E, and when C is not present, E doesn't occur. So that would be a stronger link between C and H. It's not definitive, but it makes it stronger. If we could rule out other factors, it would make C much more likely. So let's look at Mill's method for methods from the philosopher John Stuart Mill in the 1800s, who developed methods that are still used today. The method of agreement: if factor C is present in all occurrences of H, it makes it a more likely cause of H, not necessarily the cause of H, but a likely one. The method of difference: when the factor C is not present, when never present when H occurs, then we can rule out C as a cause of H. The method of agreement and difference: C is present when he occurs, not present when he doesn't occur. That makes C a more likely cause of H, and if we could make it more conclusive, we could rule out other causes. So finally, inferring the best explanation, occurrence D exists or happens. Hypothesis H explains occurrence D. It is the best hypothesis we have, therefore it is probably the probable hypothesis. Doesn't mean we can't find another one later that's a better one. It's just the most probable one among the ones that we have. So we conclude this third video on how to analyze arguments. At this point, in subsequent videos, we will take a look at some longer articles and use the ARG method to analyze their strength, whether they are strong or weak.